PID-based automotive electronically controlled power steering system in the Internet of Things environment. It is difficult to adjust parameters automatically to obtain the optimal control parameters, and the steering performance of the system is often not ideal. In order to solve this problem, this paper designs an automotive electronic control type power steering system based on PID under the Internet of Things environment. A switching tap-down circuit is composed of the combined power supply mode, and then the drive circuit is designed, and the output end is flexible, configured through the control pin. In the software design part, the vehicle system dynamics model is established by analyzing the steering resistance torque and then the proportional relationship between the power assist torque and the motor current is determined. Finally, the PID control algorithm is designed to set the control parameters automatically. Finally, the main program of the control system is set up, and the bus is used as the connecting medium to control the driving torque of the vehicle. The experimental results show that the system has good steering performance. With the rapid development of the automotive industry, people have higher and higher requirements for vehicle performance. Among them, the performance that attracts the most attention is the smoothness and handling stability of the vehicle. The environmental controlled power steering system of the vehicle is a key component that affects the ride comfort and handling stability of the vehicle. Therefore, the research, the development of the vehicle steering of the vehicle, the power steering system assists the driver in steering the vehicle by providing steering power. In the process of the vehicle steering, in order to improve the steering portability and steering stability of the vehicle, reasonable and effective control of the electronically controlled power steering system is the key to ensuring its good performance. PID controls the torque output of the booster motor by converting the current signal into the control voltage signal, so as to achieve the control effect of the electronically controlled power steering system and improve the smoothness of the vehicle, the steering stability, and the ease of steering. Comprehensive performance is of great significance. Therefore, this article design a PID-based automotive electronically controlled power steering system under the Internet of Things environment to promote the industry development of my country's automotive power steering system and enhance the international competitiveness of the automotive industry. The design idea of this system is as follows. The combined power supply mode is used to form a switching step-down circuits by using the internal switching mode and the external circuits. Then the drive circuit is designed and the output and is flexible configured through the control pins. The steering resistance moment was analyzed. The vehicle system dynamics model was established. After determining the proportional relationship between the power toggle and the motor current, the power steering control algorithm was designed based on PID, so as to automatically set the control parameters. The hardware design of automotive electronically controlled power steering system based on PID in the International of Things environment. The hardware circuit of the automobile electronic controlled power steering system is the basis for the implementation of advanced engine control methods and the control strategies. Therefore, research and development of the reliable and good performance hardware circuit board is of great significance. The main model of the hardware circuits was analyzed below. Power model design. The power supply of the controller is an important guarantee for the normal operation of the power steering system too. So the design of the power supply should meet the following requirements. The first, when designing the power supply voltage of the MCU I/O port, the compatibility with the input level of the peripheral drive circuits should be taken into account. Second, the voltage of the ADC model must be correct, and the voltage value must be greater than or equal to the voltage value of the input signal. Third, the current load capacity of the power supply circuit should meet the requirements. Fourth, in order to make the circuit low power consumption, stable performance, and good electronic compatibility, according to the actual situation, to choose the best power supply model. The design of hardware drive circuits model of the power steering system is compatible with the requirements of the vacuum digraph and linear circumference value of the drive circuit. So the conclusion is, in this paper, the design of automotive electronic control type power steering system based on PID under the Internet of Things environment is carried out from the hardware and software aspects. In design process, the combined power module is first adopted, and the internal switching mode and the external circuit are used to form a switching step-down current circuit. Then the drive circuit is designed and the output end is flexible, configured through the control pin. Based on this, the steering resistance torque is analyzed and the vehicle system dynamics model is established. After determining the proportional relationship between the power torque and the motor current, the power steering control algorithm is designed based on PID, and the control parameters are automatically set. The experimental results shows that the system has good steering performance and good power steering effect, which is beneficial to the safe driving of the vehicle. However, the work in this paper is only theoretical stimulation study. It is a pity that the design system has not been tested on the bench and the actual vehicle. The effectiveness of the model and the accuracy of the control need to test in practice. This needs to be solved in the future research. Thank you.